stopped at the end of the, where is my page I'm looking for? There we go. At the end of the instruction, I've opened the 2 instruction practices that we are starting today, or that we're doing today before we go into today's assignments. So let's go ahead and open the Galilean gravity instruction practice. We're going to work through these together. Okay, earbuds out for me. All right. So we have here the animation practice for the Galilean gravity. What we're looking at here, objects in a vacuum fall at the same speed regardless of their mass. However, if we were to drop a rock and a piece of paper outside of a vacuum, the paper would fall slower due to air resistance. So let's create a simulation of this phenomenon. All right, so what we have to do is we have to make the paper and rock fall from the tower. The paper should move at a slower speed than the rock. Make both objects stop falling once they reach the bottom of the screen. And if we play it or run it from the get-go, you have all your objects there, but they aren't yet doing anything. They are just sitting there. First off, asking this question, what speed do we need to do in order to make it fall on the y-axis? I just said it. we need to make changes to the speed.y for one thing, okay? So let's look at these requirements here. And your solution has them falling from the top right of whatever this is. I don't know what it is, from the building, okay? Okay, so let's get your code open. And hang on. All right, so we're starting out and we have our sprite setup. We have the background in there with coordinates of 0, 0. We have the tower, the rock tower, 90 and 0. We have the paper small sprite, which is set at 450 and 125, and the rock sprite, which is at 550 and 150. Remember then that we have to create the scene by adding the object to the window. Those things have been done for us already. And then it takes us to falling logic. So the falling logic has the rock speed at 150 and the paper speed at 75. So it's got the paper moving at half the speed of the rock, which is what it wants, right? And then... Oh, whoops. I'm on the wrong one. Hang on. I was wondering why it had that. Okay. So we have to do the falling logic. Okay, I knew that there was something wrong there when I did that. So what we want to do is we want the rock to be twice as fast as the paper. So we're going to put in rock.y speed, and remember it's y underscore speed equals 150. Go ahead and put that in. And then we have to put in the paper y speed, and it's going to be half of that. So it's going to be 75. So 2 lines of code there under falling logic. Rock.y speed equals 150, paper.y speed equals 75. Okay. Now, if we look, we have a main loop that has been started and finished. We have while window is running and window finish frame. But we need to put some stopping logic in there. So basically, we want to make sure that the rock and the paper stop on the bottom of the screen, that they don't fall off the screen. I don't think it was this class. Somebody had seen in the stuff that the height of the window was, I think it was like 550, give or take a couple of pixels. I don't remember exactly, and I don't remember where they found it, but that's why we have 530 and 110 here as the numbers. So what we're going to say under the stopping logic is if rock.y, that means on the y-axis, is greater than or equal to 530, then rock.y speed changes to, what do you think? 0. Good answer. And then we have a second if statement. If paper.y, yep, is greater than or equal to, and we're going to put 510 instead of 530, then we are going to change the paper y speed to 0. So once you get that in, I need for you to run your code, make sure that it works. And once you make sure that it works, then I need for you to hit the submit button. Okay, has everybody gotten that? Do I need to wait for anyone? Okay. Then let's go ahead and open up the next one, which is Smell the Roses. And again, we're practicing animation here. Sometimes you need to remember to just stop and smell the roses. Give the flower Knight a much needed break when she reaches the flower. So your requirements are to make the knight run towards the flower. When the knight reaches the flower, stop her movement and set her animation rate to 0. So the code assist keywords are your X speed and your animation rate. Okay, so we're going to look at, we're going to look at the code here. All right, so we have the TS app imported. We have a window started. We have our sprites, background, night, and flower. And then we've also scaled our flower to 0.5. We have added our objects to the scene. Notice that you have your instance names there. And then we come down to line 28, and this is asking us to start our animation. Okay? So it was the night that we need to worry about. And so let's set the, actually let's look at this first before we do this. So when we start it, the night is already running. It's using a sprite sheet. We're trying to get it to reach the flower. Okay? So what we need to do is we need to set the night speed, the night X speed, rather, to 100. Night.x_speed equals 100. And then once you put that in, you're going to see your animation running over to the flower. But it also passes the flower. Which brings us into our main loop. This is where we check our conditionals. So while the window is running, under the smell flower, we're going to say if night.x, so we're checking the x position, is greater than 500, then we are going to night.x speed, set it at 0, and we are also going to change the image animation rate to 0 as well. When you finish, check your program. When it gets to the flower, when it reaches the flower, it should stop. Not only should it stop at the flower, so the X position stops, but the animation stops as well. Okay, so you have if night.x is greater than 500, you are changing the X speed to 0 and the image animation rate to 0. Okay, do we have any questions? All right. Make sure you hit the submit. And then we're going to go to today's. I got rid of the warm-up for today because I knew that we were doing some leftover stuff from yesterday. So we are going to go straight into the 2 coding demos. The first one is reverse direction. And all right, so we're going to learn a coding technique called reverse direction. It'll help us make sprites move back and forth, okay? So reverse direction changes a sprite's horizontal or vertical direction while keeping its speed the same. So this technique we'll use when we want a sprite to bounce or change its direction without changing its speed. It's particularly useful when a sprite's speed is variable due to being random, changing, or entered by a user. One example is if we're making a game like Pong, where we want the ball to bounce if it hits the side of the screen. Other examples might include an animation of a character walking back and forth, a loading indicator where a circle moves back and forth with a bar, or maybe a basketball game when the ball hits the rim or backboard. Okay, our general syntax for this, for changing a sprite's speed, is sprite.xspeed, sprite.yspeed, and then it equals an integer. So how can we use this speed parameter to reverse its direction? Does anyone see a way to be able to do that? Yes. All you have to do is change the integer from positive to negative. It's going to change it. It's going to flip it the other way. Okay? So let us open the code from this assignment. All right, and if we go ahead and run this one, to start off, we have, I don't know, a beaver or an otter. And I don't know if you saw that periodically it's changing. When I say changing direction, it's moving along one way along the x-axis. However, the image is flipping back and forth, okay? So, every 3 seconds, the sprite flips around, but it keeps moving in the same direction. So how would we make the otter reverse its swimming direction instead of just flipping the sprite? So we want to add the following line to the end of the then block. Hang on. I'm reading something real quick. Okay, so on line 35, it's part of this if statement, but I'm putting it under the code. And it's swimmer.xspeed asterisk equals sign. Okay, so it's multiply equals -1. And what the if statement is checking for is to see if the frame is greater than the lap duration. Okay, so lap duration was set to 60 up here in the timing variables, and the frame was at 0. So as it runs through, remember it's changing every 3 seconds, right? So if our frame rate, and I don't see, does our frame rate, is our frame rate set up in here? Yeah, I don't know exactly what our frame rate is. However, as long as we are above 60, it's going to reverse it. So let's go ahead and run it. And there it goes. Based on the timing of the animation, it is switching. Okay? So there's also a more readable way to code the same thing. Just like a number, we can change the value of a variable from positive to negative or back by putting a minus sign in front of it. So we're going to change the code that we just wrote so that instead of it being times equals -1, we're going to make it equal to negative swimmer.xspeed. Both of them work. but you have swimmer.x speed, that variable up here, determined with a random int. So all you have to do is reverse that variable. And if you run the program, it should do the exact same thing. Okay? So right here, all you did was change the multiplication equal sign to just an equal sign, take out the -1, and put negative swimmer.x speed. Okay, when you finish, hit submit. And we'll look at the scrolling background. And I know someone yesterday in one of the classes had questions about the scrolling background. Okay. Is everybody ready, or do I need to wait a minute for you to finish typing that code? Because I still see a few typers. I want to make sure you guys get it. Okay, so we're looking at scrolling background. We're going to learn a coding technique called scrolling background that will help give our graphical programs more exciting backgrounds. That way they don't sit still, okay? So a scrolling background is simply a background that appears to be constantly moving in a certain direction. We'll use this technique when we want to create the illusion that a background can move forever. One example is if we want to make a game or animation about a character running for a very long time with scenery moving by in the background. What are other examples? We can do a driving game. We can do a meditation app where the sky and clouds move as well. So, a scrolling background looks a little like the screen or camera is moving, but it's actually done by using the background sprite. In these pictures, the white box is what's in our window. By moving a background that's bigger than the window, we can make it appear to scroll or move. Okay, so it's got to be bigger than. And I'll also tell you, and I know that the TechSmart has this done for you. When you do this on your own, though, it's important that you have this seamless edges, because if you look at these, you're going to notice that this graphic right here is the same as this and this. It's just been split in two from the left to the right, so that when it repeats itself, it is truly just repeating itself and going on and on. You can't tell where the graphic stops and starts. Okay? So let's switch to the code view. And let me make sure I've got the right one. Yes. Okay. So let's run the program once, see what it does. We have right now this car that's sitting in the middle of a street, highway. Nothing else is happening, okay? We could animate the car and have it move from left to right across the stage, but then you're limited with how long that happens. However, if we leave the car there in the middle and animate the background, we can have it go forever and ever, and it seems like the car is continuously moving. So we want to first, before the main loop, so right here in background scroll, line 22, we're going to put in bg.x speed equals -600. BG is often an abbreviation for background. And you can see that background variable up here The sprite is using Night Street scrolling.jpg. Okay, and then let's run that program. Okay, and you see, excuse me, you see that it moved. Now, eventually, though, what happened when you ran it? It ran out of background. Okay. All right, so we're going to figure out how to fix that. Let me go back to the slides. All right, so all of the scrolling backgrounds in the library are 2 screen lengths wide. That means when the background would move off screen, we can move it by 1 screen length to give it more room to scroll. It doesn't look like the screen is moved at all because of the seamless edges. Okay, so let's go back to our code real quick. And you'll notice that we have a loop while window is running, and inside of that, we have the background loop. So what we need to do is put in an if statement, and it's dealing with the width of the window. So if bg.x, okay, meaning the position of the background on the x-axis, is less than or equal to negative window width, then bg.x plus equals window width, meaning it's incrementing window width. Okay, and once you have that, go ahead and run your program. Make sure that that works. You should have a seamless transition from one background to the next. I should say from one background to the next. It's the same background, but it should be looping continuously now with that code. So the code that you want to remember for this is bg.speed equals -100, and the if statement bg.x is less than or equal to negative window width. Then you will increment bgx by window width. Okay, so note that instead of adding the window width to the background's x, you can set its x to 0. The two will usually work the same, but if your background is moving really fast, setting its position to 0 may cause a small gap in the loop. So, in order to change in order to make our background move to the right instead, every line would have to change. So the first line's literal should be positive instead of negative to move right. Then we'd have to change the condition to remove the negative from the window width, and then reverse the operator. So then it would be decrementing window width, but you could change the direction that the background moves by just flipping the values there. Okay. Let's go ahead and submit those. All right, so we have 4 practices here, 2 for reverse direction and 2 for scrolling background. I'm going to go ahead and open the reverse direction and the scrolling background. I'm going to work through those with you, and then you can do the next 2 on your own. So reverse direction 1. All right, so again, that's changing the sprite's horizontal or vertical direction while keeping its speed the same. And then you have some code here that is going to help you figure that out. So you're going to open up the keep Froggy grounded. And the solution that we want to see is that this frog jumps up and down and up and down. Okay? At the moment, though, it's going up off the page. So, let me get this to where I can see everything. All right, so we have the graphics set up. Let's look at your speed variable. Right now you have the frog.y speed set at negative 250. When it's going negative 250, what direction is that going? Up, okay? Now let's go ahead and look at the while window is running. We have two things we need to add here to make this work: the frog position and the frog direction. So we need, for frog position, if frog.y is greater than or equal to 350, or frog.y is less than or equal to 50, then we are going to change frog.y speed equals, what do you think it's going to equal? Negative frog.y speed. Oops. Okay, so check that, see if you got that to work. Okay, go ahead and make sure you hit submit. And then let's look at the scrolling background. All right, so remember, your scrolling background appears to be constantly moving in a certain direction. Couple things of code you need is you need to set the speed of the background, and you need a conditional checking to see if the X position is negative window, some type of window width, whether it's negative or positive, depending on which way you're running it. Okay, so let me run this solution. So we have here a, I don't know, a wizard and his something appear to be, they're moving up and down because that's part of the animation. But then you have the Stonehenge background moving constantly, okay? So when we run it right now, all that happens, oops, hang on. When we run it right now, all that happens is the animation of the wizard, okay? So we need to, again, we have all of our sprites set up in the window. We need to set our background speed, okay? So we are going to change or set the background speed, background.x speed, and we'll set it to negative 100. Then inside our main loop, we have the window running, and we have something in the background reset that we need to take care of. So what do you think that we are putting in here? Are we putting in a conditional of some kind? Somebody tell me what that should be. Logan. Remember, we're doing background here. So the background is what? It has a certain width to it, right? What? Window width. Okay, so if the background, if their X position is less than or equal to negative window width, then background dot X, the X position, is going to increment by the window width. Okay, so what I need for you to do once you have that is to run it, see that it's working, and I will unlock the next two exercises for you. Reverse direction 2, scrolling background 2. Remember to refer back to previous code if you get stuck. Work your way through it and see if you can't figure that out. Remember also to hit submit when you finish, and if you don't finish those two in class today, then you do need to take care of that for homework tonight.